Welcome back to Learn with me, Ms. Killen here at MPB. We are in our Unit 8 exponential functions. We are on Lesson 3 today, so let's look at it. We have exponential functions graph foundation. I can use and describe ending behaviors along with y-intercepts, growth and decay rate of the graph of the function. We are looking at FIF4. So let's go ahead and dive in. Our exponential equation we have learned is f of x, or we also know f of x as being what? Y equals, good job, a times b to the x. Now, one thing I want us to see on this slide, so let me grab another color. If we are going this way in our graph, it's going to be a growth. But if we are going this way in our graph, it's going to be a decay. So we need to make sure that we have that distinction of a growth and decay, which when we're in our biology classes, we see a lot of those growth and decay graphs, so we need to make sure that we're understanding how to read them. All right, so let's look. So we talked about growth, and then here is a wonderful example of growth. We see that we're starting out slow, 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 and then all of a sudden we are growing. So whatever this graph is representing, it is growing. So then we have a wonderful representation of decay. So it's going down, then all of a sudden we are really going down. So that is what we're looking at when we say the growth and decay. Key features we need to remember are, so obviously my y-intercept is my a term when we're looking here, so this is going to be my y-intercept. Then my common ratio, okay, that's my b. So this one down here is my common ratio, and we're needing to make sure that we are putting this in our notes. So then, what does this mean? Common ratio. What am I talking about? A common ratio. So let me go ahead and give you a chart that we can look at and see if we can see those common ratios. So here we go. So let's say I have my x and y values. Let's say we have -1 and I have 4/3. 0 and 4. 1 and 12. 2 and 36. 3 and 108. Now, Ms. Killen, what in the world are we looking at? Okay, this graph is showing you your x values, and this graph is showing you your y values. So obviously, I know where my y-intercept is. It's right here. But my next question I want us to see is, what is the common ratio? What is the common thing that we're doing to change from point to point? Remember when we started this unit, I said that the next point always has to refer back to my previous. So when I start here, what do I do to go from here to here? I want you to turn to your table partner and say, what do you do to go from that first point to that second point, and see what you can come up with. All right, what I think we're doing is we are multiplying by 3. Well, are you sure, Ms. Killen? Does that go every single time? Let's check it out. All right, so 4/3 times 3 to 4. So if what we came up is true, when I go to 4 and multiply by 3, I get 12. Well, that's true. So let's try the next one. From 12, if I multiply, do I get 36? Absolutely. So then when I go from 36 to 108, and I multiply by 3, do I get that product? Absolutely. So when we're talking about this common ratio, we're talking about what we're doing. What are we doing to go from one point to the next? So there is my formula. So let's see this. Let's make sure that this is going to happen. So let me put in the table that we just came up with. So let's go ahead and put this in our calculator. While I put it up here, I want you to put it on your calculator too. Now remember, to put the table in, we go to Stat, and I'm going to go to 1 to edit. My L1 is my x value, my L2 is my y value. So I have -1, enter, 0, enter, 1, enter, 2, enter. I'm going to scroll right to put in my y values. Now, we have a fraction. So let's put 4 over 3, enter. Then I've got 4, enter, 12, 36, and 108. So we put in our table. Now we need to go ahead and pull that equation. So I'm going to press enter, and I am going to make sure that, I missed something. Ms. Killen didn't put the 3. Always got to make sure that you put all the x values and all the y values. That was a good catch. So now let's go back to our second quit, go back to our original screen, go back to our stat button. But now we've got to do some calculations. So I am going to scroll right to calc and go all the way down. We're reading, and we're looking for that exponential regression. So there we go. My x's are going to be my L1, my y's are going to be my L2, and we're going to go down to calculate and press enter. So we notice that my y-intercept is a 4, and then we said that our common ratio was a 3. So we have it right there. That proves that the math that we did here, it proves the 3 is my common ratio, and we know that 4 was my y-intercept. So now we have yet another tool in our toolbox to check our math. Good job. Let's look. It says, remember, the formula f of x equals 2 to the x is the same as saying f of x equals a times b to the x. You can always put a 1 in front. Now, when we see this, and we have this f of x equals 2 to the x, obviously this is the b. But Ms. Killen, we don't see anything to represent that a. That is true. But what do we know about anything that's not there? It's an understood 1. So we could always put, that's the same thing. We're multiplying by a 1. It's not going to change the value. So if you need to put that 1 in there as a placeholder, by all means, placeholder away, because we want to make sure that you're seeing all the different terms. So it says, let's do some practice. Look at this function. Let's draw the graph. Well, the first thing that we need to do is what? Let's look at the table. So I'm going to put an x and a y. So how can I find the points for this graph? Well, we know that we have a 1 right here. So my 0, 1. Now, how do I come up with my other points? What would I do? So the first thing I can do is put my x values. Obviously 0, 1, 2, and so forth. So let's put that 1, 2, 3, and 4. Now, what do I use to go to my next y values? You're right, my common ratio. Well, what is my common ratio? It's a 2. So I'm going to multiply the previous point by 2, multiply the previous point by 2, multiply the previous point by 2, multiply the previous point by what? 2. So now I have my whole table. So it's not going to be hard for me to make this graph. Let's go ahead. I'm going to put it on the board. You put it on your paper, and let's compare. So 1, 2. So let's do 2, 4, 6, 8, 10, 12, 14, 16. I'm going to go by 2s on my y just so I have enough. And then I'm going to go by 1s here. So let me get a different color so it'll look better. So 0, 1. So it's going to be about right there. 1 is 2. 2 is 4. 3 is 8. 4 is 16. So we can see that it does have that exponential graph feature. It is that curved up. Now, could we say this is a growth or decay? The way it looks, it's growing. So that's a good job. That's a good way to recognize if these are growth or decays. Good job. All right, so here is what we drew, and there is what we got for our graph and our table. So now, what I want us to look at is ending behaviors. So, Ms. Killen, not quite sure what you're talking about, some ending behaviors. So, if you study, the ending behavior is you're going to get good grades. If you don't study, the ending behavior may be you don't have good grades. So, when we look at graphs in math, we also have ending behaviors. Let me show you what I'm talking about. Is this an increasing or decreasing graph? We've already said that it's increasing. So it's increasing. Now, explain the ending behaviors. So as my x's increase, meaning get bigger, as my x's increase, what happens to my y values? So I had 0, 1, 1, 2, 2, 4, and so on. So as my as my x's increase, what happens to my y values? They also increase. Good job. So then as my x's decrease, as I go this way, as my x values decrease, what could we say about those y values? They are also what? They're also decreasing, but I could also say that they are approaching 0. So in this graph, if we kept graphing, it would keep going and going and going, but never quite getting to that 0 or that x-axis. So this is what we could say about the ending behaviors. The ending up here keeps increasing. The ending down here keeps decreasing as it approaches my 0. So good job. So let's look now. It says use the following function to sketch the graph and fill in the table. Answer the questions for the data. So first, let's go ahead and work this. I'm going to work it up here on the board. You work it on your paper, and let's compare. So here we go. So I have my y equals 1/3 x. I know that I am using y equals a b to the x. Since I'm not seeing an a, I know it's an understood 1. So I have my x value and my y value. 0 is going to be at 1, so I'm just going to look for 2, 3, 4, and 5. So we said this one has to be my common ratio. So I'm going to say that I'm going to multiply this by 1/3. So when I put that in my calculator, 1 times 1/3, I get 1/3. So again, I'm going to use my common ratio and multiply, and I get 1/9. Using my common ratio, I get 1/27. Use my common ratio one more time and get 1/81. So there I have filled out my whole table of my x and y's for 0 to 4. So let's go here and see if we can graph this. So I've got 0, 1. And then I have 1/3. So I'm going to say it's about maybe right here. And then I have 2 at 1/9. So that's going to be about maybe right here. 3 at 1/27. So that's going to be about right here. And 4 would be about right there. So if I graphed this, what could be said, and remember Miss Killen can't draw a straight line to save her life, what could we say about this graph and or table? That this is a what type of exponential function? It's decreasing. And we see that it's a decrease. We see that going from 1 to 1/3, and then from 1/3 to 1/9. Remember, as I get further away from 1, the smaller the number. So then I can see that this is decreasing. So here it is. So now that we've found the chart and we've also graphed it on the graph, let's answer some questions. It says describe the graph as increasing or decreasing. Well, we've done that. We can tell that it is a decreasing graph. Now complete the ending behaviors. So we have to make sure that we're understanding what this question is asking. As x or my x values do something, what do my y values do? So let's just go. As my x values get bigger, 1 to 2 to 3, as they increase, because I'm increasing in numbers, what happens to my y values as those x values increase? They are decreasing. They decrease or they approach 0. They decrease and approach 0. Now, what happens when I go the other way? As my x's decrease in value, what happens to my y's? They increase. All right, could this graph be considered a growth or decay? Now, it's decreasing. So if I'm decreasing, am I growing something or is something decaying? It's a decay, absolutely. Good job, guys. All right, let's look at number 3. Consider the following equation when answering the question. So we have y equals negative 3x. We have complete the table, label the equations, sketch a graph of the equation. Is this increasing or decreasing? And describe the ending behavior. So let's go ahead and look at this. Obviously, we have y equals a times b to the x. This is going to be my common ratio. And I know that 1 is there, it's understood. So I have my x and my y. Now you may be asking, Miss Killen, why do you always put that x and y at the top of your graph? The reason I do it is to keep myself focused and organized, because I don't want to sometimes forget I put my y at the beginning or my x at the beginning. I want to make sure I know. You always put that x first, you always put that y first, but that was a good question. All right, so I know that this is my y-intercept, so 0, 1. So I'm going to find 1, 2, 3, and 4. So my common ratio is going to be that negative 3. So let's go ahead and multiply by that negative 3. So 1 times negative 3 is negative 3. Then I'm going to multiply by that common ratio again and get a positive 9. Multiply by that negative 3 and get a negative 27. Multiply by that negative 3 and get a positive what? Let's pull our calculator out. So I've got negative 27 times a negative 3, and I get a positive 81. Ms. Killen, that goes back and forth from positive to negatives. Do you remember in our first lesson where we talked about those geometric sequences? This is something like that geometric sequence. So yeah. All right, so let's go ahead and graph this and see what this looks like. So I've got 0 at 1. So let's say 0, 1. And then I have 1 at negative 3. And then I would have 2 at 9, which is going to be up here. And then I'd have 3 at negative 27, which would be down here. And then I had 4 at 81. So, Ms. Killen, that looks a little strange. It does, doesn't it? Sometimes these exponential functions are going to look a little strange in what we have. So we need to make sure that we are multiplying by our common ratio. And like I said, sometimes they're going to look a little strange. Sometimes you're only going to see this portion of your exponential function, or sometimes you'll just see this portion of your exponential function. So you're going to need to make sure that you've done the math correctly and make sure that you're understanding what's being done with that a and b value. Good job. All right. So time for you to master. Let's use y equals negative times 1/2 to the x for these questions. Remember your x and y values, where they go. You need to complete the table, label the equation, sketch the graph, depending on if it's increasing or decreasing, and then describe your ending behaviors. So you and your table partner, go ahead and work these. Once you get this done, come back to me and let's see what we got. Okay, so let's go ahead and label what we have with this y equals negative 1/2 to the x. So I've got y equals a times b to the x. So normally I say it's 1, but now it's going to be a negative 1. So let's go ahead and put our table in. So we have 0, negative 1. Now, what is our common ratio? That 1/2. So let's go ahead and multiply by that 1/2. So negative 1 times 1/2 is going to be a negative 1/2. And then I'm going to multiply again by that common ratio, and I get a negative quarter. And I'm going to multiply again by that common ratio, and I get a negative 0.0625. Whew, those are getting some small numbers. So let's go ahead and graph this. So I've got 0 at negative 1. I have 1 at a half. I have 2 at negative and a quarter, so that's going to be about right there. And then I have 3 at a little less. So what could I say is happening? Do I have an increase or a decrease? Yes, I have an increase. So then what about those ending behaviors? As my y's go this way, which is increasing, what could we say is happening, as my x's increase, what could we say about my y's? They are also increasing and approaching what? Yes, approaching 0. Now, what about if my x's go the other way and they decrease? What could we say? As my x's decrease, what's happening to my y's? They are also decreasing. Good job. So as my x's are getting bigger, so are my y's, but they're approaching 0. And as my x's are getting smaller, so are my y's. They are getting smaller and smaller. Good job. So some things that I don't want us to forget, what our y-intercept is and what our common ratio is. I don't want us to forget what our ending behaviors are. What's happening as my graph goes on and on and on? What's that looking like? Or what's it looking like when it goes to the other way? What my A is, what my B is, and what increasing and decreasing looks like, and what decaying and growth looks like. So we've looked at all of those in this lesson. So I am wonderfully glad that you are learning with me. This is a very hard subject, but you are going to persevere and you're going to get this because this is going to be the easiest thing that you can do then. So, as always, thank you for learning with me, Ms. Killen here at MPB, and have an awesome day.